We'll continue our digression, this time with looking at what the implementation of state monads is, which is really easy given that the basic structure of monads and implementation and do notation has been implemented. That is hard, of course, but that's been done in the lean core. Okay, so what is a state monad? If we have a state, then if alpha is a type, then something of the type state S alpha means it's a term of type alpha, but it depends on an initial state. Okay, and returns a final state. So both of these are of type S. So it's essentially a function which, given a state, gives you alpha cross S. Okay. In fact, it is the same thing wrapped in a method which is called run. When you run the monad, you get from the initial state, you get the value you're interested in and the final state. Okay. So I'll talk about the value in the monad state S henceforth. So this is what it is, but the thing is we get lots of nice notation from the monadic structure. So first of all, let's see what are the basic methods. We can get a state S. We can get the state S, but not just as itself. What we can get is as a state in the monad. So it's state SS, and that is obviously just the diagonal. Okay. We can also put the state or set the state, but I've simply implemented update instead. If you have a function which changes the state, you get an element of type state as unit. That is, you're getting a unit in the monad. Now, unit has a unique value, and in functional languages, unit is returned means we are just doing a side effect where there's no information in what you returned. And here the side effect is the state changed. So what we do is we take the initial state, we return the unique value of type unit and fs. So that is the new state. Okay. And then there's a convenience method that we use. Very often we need to only the final value of, that is the value of type alpha, and not the final state. Okay. Furthermore, we may have a default initial state. If we do, we can run it starting with the initial default state or the any given state and dump the final state. So we return only the value alpha. So this is used heavily in lean in various of its monads. What makes this interesting is that monads have this very nice do notation, and this is what is called a monad. Okay, whatever that is abstractly, in this case it means two things. One is very simple. We can think of, for example, a natural number as a natural number in the monad, and that is in a very simple way. Just ignore the state. Namely, if I have a number 3 and whatever the state is, I return 3 and then return the state which I got initially. Okay. More interestingly, suppose we have an element x and this is in a term of type alpha in the monad, and we have a function f which will take a function of is a function whose domain is of type alpha, alpha dagger here, and returns beta, but not beta by itself, beta in the monad. Okay. So that is state as beta. Well, if there was no in the monad, you of course can compose them and get f alpha. And the point of the monad is that you can compose them nicely. Namely, you start with x, run it with the given initial state. So we have a given initial state, run it with a given initial state. You'll get a value of type alpha, alpha dagger in this case, and a final state. Now I'll take that as the initial state of my next step. Okay, now f of a is in the monad and it has type b in the monad. Okay, so when I run that on S prime, I get an element of type beta, sorry, not B, and a final state. And I return that final state and the element of type beta. So these can be composed. This lets us compose things in a very nice way. Okay, and one convenient thing which has been implemented in lots of these monads in lean is we have a wrapper method which lets you evaluate things in monad, provided you could evaluate the original term. So here I'm just running it and evaluating it. Okay. So this was just an implementation. It is easy. The moral again is that lots of details when you work with them can be hidden away. We deal with states only when we need to, and otherwise we extract things from monads and states are taken care of automatically.